Hey everyone, in this video we're going to create a function to toggle the character's gait and apply different movement setting profiles to the character movement component based on a selected gait. I'll show you how to set up a new input action for aiming so that the character switches from jogging to walking when the right mouse button is held down. We'll then pass the character's gait to the animation blueprint using a blueprint interface, and I'll show you how we can bind an update function to a single sequence player node that handles all the logic for selecting an animation to play based on our character's gait and direction. There's a lot to cover in this video, so let's get started. To begin, we need to give our character an understanding of the different types of gaits that it can have. I introduced the concept of the enumeration in the previous video, and I'll use one again here. This time, I'll name it E_Gaits. I'll open it up, and inside of it, I'll add two enumerators. I will name the first one walking, and the second one jogging. I'll go ahead and save and close out of this enumeration. And next, I'll open up our third-person character blueprint. I will create a variable of the type of the gait enumerator that I've just created, named currentGait. Now that we have this currentGait variable, we can use it to keep track of the gait of our character. Whenever we change this gait variable from walking to jogging or from jogging to walking, we want to update some variables within the character movement component. I'm going to create a function that will have exclusive control to set this currentGait variable. That way, inside of this function, we could also set the other variables that we require to be set. I'm going to mark this currentGait variable as private, which means that any other class which has a reference to this character cannot access this currentGait variable, meaning that this character class has exclusive control over the variable. Next, I will create a function, and I will name it updateGait. I will give it an input named desiredGait, and I will set that input type to the gait enumeration. I will set the currentGait variable, and now we need a way to assign sets of values to our gait enumeration. The character movement component has a variety of walking settings, and I would like to build the system in a way that these walking settings, well, many of them, we don't need them all, can be modified by the currentGait so that we can change the maximum walk speed for a gait, but also some of these other values as well, such as the maximum acceleration and braking deceleration. To do this, I will again use an approach that I introduced in a previous video and create a struct to contain all of these settings. I will create a structure, and I will name it f_gait_settings. I will open this structure, and inside of it, I'm going to set this first variable to be a float, and I will name it max walk speed. I will add another float named max acceleration, and another named braking deceleration, another named braking friction factor, a boolean named use separate braking friction, and finally, one more float named braking friction. I'll go ahead and save and close out of this struct. Inside of the character blueprint, I'm going to create a new variable, and I'm going to name it gait settings. And I will set its container type to be a map, which gives us a second value here on the side that we can set, and I will select our structure for our gait settings. I'll go ahead and compile. That way we can access our gait settings default value, and I'm going to add an item into our map. Now, if I try to add a second one, it's going to give me an error that says that it cannot add a new key to the map while a key with the default value exists, So I'll need to set this key to jogging so that I can add walking onto our map. I'll expand both of these, and I'll go ahead and enter some values here. For the maximum walk speed of jogging, I'll set the value to 400. Max acceleration will be 800. Braking deceleration will be 800. Braking friction factor will be 1. And use separate braking friction will be false, so we do not need to set this braking friction value. For walking, max walk speed will be 200. Max acceleration will be 400. And braking deceleration will be 400. Braking friction factor will be 1. Now, you may find that other values will work better for you, and I'd really encourage you to experiment and play around with these, as these are going to be the values that define the movement feel of your game. Now, we need to set these settings inside of our character movement component based on our gait. So what we can do here is take this gait settings map, drag out from it, and search find. This find node can take in an enumerator of our Gaits enumeration type. In this case, I will plug in our desired Gait input, and it will output the item from this map which corresponds with the Gait that we've input. So I'll drag out from this struct, and I will break the struct. I'll expand it, and here we have our settings that correspond to our desired gait. I'll drag the character movement component into the graph, and I will go ahead and get a set node for each of these values. I do want to note that the name of the braking deceleration variable that we'll be accessing here is braking deceleration walking in the character movement component, so that isn't what I named it in this struct. Now that I have all of these variables, I'm going to plug them in so that we set them after we set our current gait variable. And I'm going to make sure that all of these settings are plugged into the corresponding set nodes for these variables inside of the character movement component. I'll go ahead and compile this and go back into our event graph. I'll go ahead and drag out this update gait function and plug it into our string of nodes coming out from the BeginPlay event. I'll set the desired gait to jogging, and this will now be the default gait for our character, and these settings will be applied whenever we begin playing. For the first situation where we want to toggle the character's gait aiming, I'm going to first open up the content browser and navigate into the input folder that is inside of this third person folder. Inside of it, I'll open up the actions folder, right click, and under the input section here, I'll select input action, and I will name this action IA_aim. There's nothing else that we need to change inside of this action, so I'll save it, back out to the input folder, and enter into the default input mapping context. I'll add a mapping. I will select our aim input, and for the first keybind, I will choose the right mouse button. I'll add another, and I will search for gamepad left trigger. I'll go ahead and save this input mapping context and go back into the third person character blueprint. Down underneath the jump input section, I will go ahead and right click and search for IA_aim and select the aim enhanced input action. I'll drag our update gait function into the graph again, and I will plug it into the started pin, and I will copy, paste it, and plug it into the completed pin. For started, I'll leave the desired gait as walking, and for completed, I could set it back to jogging. However, there may be a case potentially where the character was walking before they've aimed, and so it would be better to return them to their previous gait rather than a hard-coded one. I'll enter into this update gait function, and I'll create some distance here between the input node and the set current gait node. And I'll add a new variable to our character named previous gait. I will set its type to be the Gaits enumeration we've created, and I will drag it into this function to set it. I will plug it in between this entry node and our set current gait node, and I will set its value with current gait. So before we update current gait with our desired gait, each time this function is called, we first set previous gait so that we store the previous gait of the character. I'm going to add a couple of reroute nodes here to organize these lines between nodes. That way this is a bit easier to read. Now back in the event graph, I'll drag our previous gait out and connect it to our update gait node that is plugged into the completed pin on our aim input action. Now if I compile and save and go back into the level editor to play, we can see now that when I move, we are moving at our jogging speed, and if I hold down the right mouse button to aim, we move at our walking speed. The rest of the settings are being applied, but they're less visible. So our code is working. I can exit out of this, and now I can show you the implementation inside of the animation blueprint that will change our character's movement animations based on our gait. Inside of this blueprint thread-safe update animation function, I'll go ahead and select these nodes that we have here that are not collapsed into a function yet, which set the locomotion angle and our locomotion direction. I'll right-click and I'll collapse them to a function named update orientation data, and I'll mark it as thread-safe. The first step we need to take now is to access the gait enumeration from our character. However, we only have access to the character movement component right now, and instead of casting to our character the same way we cast to our character movement component within our getCharacterMovement function, I want to show you an alternative method for sending and receiving values between blueprints in Unreal Engine. Because we only want to access our character's gait and not the other values that we don't really require, there's not much sense in casting and accessing our entire character each time. So I'm going to open up the content browser, go back into our blueprint folder of our third-person template folder, and I'm going to right-click, and I'm going to, under the blueprint section, create a blueprint interface. I will name it BPI_Gait Data Interface. Blueprint interfaces are essentially a list of functions that can be given to a class that implements the interface. These functions have preset inputs and outputs and can be called from other classes and are able to fail silently. This means that if we take a reference to our animation instance and call a function, let's say to receive a gait, and plug our current gait into it, if our animation instance implements the interface, it will be called. Otherwise, the function will fail silently without issue. And we can specify the actual logic for the function that gets called in each specific class that implements the interface. So inside of our animation instance, we can take the input that we receive and use it to set a local variable within our animation blueprint. I'll open it up. For this first function that it's given us by default, I'm going to name it receiveGaitData. I will give it an input named GaitData, and I will set its type to be the enumeration that we've created previously. And I'll give it an output of the type boolean, and I will name it return value. I can go ahead and compile and save and close out of this interface. And now, inside of our animation blueprint, I will select the class settings. And under Implemented Interfaces, I'll expand this Add menu and select the Gait Data Interface that I've created. Now, under this Interfaces section, we have the function that we put inside the interface, which is named ReceiveGaitData. This is actually a function that we'll be calling from our third-person character, and we'll be inputting our current gait into it when we call it. So, I'll create some distance between these nodes, and I'll create a new variable inside of our animation blueprint named currentGait. I will set its type to be the gait enumeration that we've created. I'll drag it into the graph, and I will set it based on the gait data input of this function. I will plug into this return node, and I will set this return value to be true. Now, this return value is not completely necessary. However, I added it so that this interface function would automatically show up as a function inside of this blueprint. Without a return value, it shows as an event within the update graph of an animation blueprint and an event within the event graph of a standard blueprint. For example, if I open up the Gait Data interface, add a new function, I'll just name it example, and compile this, go back into our animation blueprint base, and now we have the example interface function here. However, it has been placed as an event in the event graph. Now, there's nothing wrong with this, but I personally prefer my interface functions to display as functions rather than events in the event graph. So I will go ahead and delete this example function out of the interface, compile it, recompile this blueprint and delete that example event, and continue on within our third-person character and enter into this update gait function. I'm going to give myself some more room here, and I'm going to drag a reference to our mesh component into this function. I'll drag out from it, and I will get the animation instance of this mesh. For the return value, I will search BPI and select the function for our Gait Data interface. Now, if the animation instance implements this interface, the function within it will be called. So I will plug this into the execution string of this function. And for the Gait Data input, I will plug in our desired gait. Now, whenever we update our gait variable inside of our character blueprint, we call the ReceiveGaitData function that is added to this animation blueprint through that blueprint interface, and we send in the gait data from our character. I'll go ahead and close out of the gait data interface, and I will also close out of the third-person character. We don't need to keep either of those open now. We have our current gait within our animation blueprint now. So I can go into the animation graph, into the locomotion state machine, and into the cycle state. And now, instead of adding 4 more animations, I'm going to show you how we can bind a function to a single sequence player that selects our animation based on logic we provide whenever the state machine starts to evaluate this cycle state. I will create a sequence player node, and I will go ahead and set the sequence here on the side to dynamic, which allows us to set it dynamically in a function that we bind to one of these conditions. We can either bind a function to be called on the initial update of this node, which is called before the node is updated for the first time, when this node becomes relevant, which is called when this node first becomes relevant within the graph, meaning that it's called when its pose first contributes to the output pose of the graph. The final option is on update, which would be every tick that this sequence player updates while it is relevant. Because we may be switching poses based on our locomotion direction, we may be switching our gait while we are within the state, we want to bind a function to onUpdate. I will expand this menu and choose the Create Binding option, and this will create a new function, which I will name Update Cycle Anims. This function has two inputs, a context input and a node input. These inputs are the same for every function you can bind to any animation graph node, as you can bind to more than just the sequence player. To tell this function what kind of node it is bound to, I'm going to drag out from this node input and type in sequence player and select the convert to sequence player pure function. Now, this result will return true or false based on whether or not this function is bound to a sequence player or not, because we can bind the same function to multiple different nodes. So I will use it to grab a branch, and I'll plug that branch into the execution string of this function. Off of the true condition, I will drag out from sequence player and I will search for set sequence, and I will select set sequence with inertial blending. It's asking for the update context of the node, which I can provide it by linking the context input to the input of this node here. And for the blend time, I will set it to 0.3. And for the sequence, I'm going to go ahead and drag first the locomotion direction enumeration into this graph. I will get it, I'll drag out from it, and I will search select. This will give me a select node with an unset type for each of our enumerators within our direction enumeration. I will go ahead and plug that into the sequence node, and that will convert all of these to the type of an animation sequence. Now I'm going to grab our current Gait enumeration, drag out, search select, and I will plug the return value into one of these directions. I'll go ahead and duplicate this 3 times and plug this grouping of nodes into each of our directions. We can now set a jogging and a walking animation for each direction. So I'll go ahead and set those animation sequences now. Now that the animations are set, I'll compile, go back to our cycle state, and I will plug this sequence player directly into this local to component node. Now I chose that set sequence with inertialized blending node inside of the update function instead of the set sequence node, and inertialization is a special type of blending which requires a specific node to be placed into the animation graph to work properly. Back inside of the animation graph, between the locomotion state machine and the IK, I'm going to place an inertialization node, which is going to save certain data about the pose of our character to be used within inertialized blends, which tend to handle the carryover of velocity between poses better than standard blends. Now I'll compile and play, and if I move around in various directions, our directions should line up properly, and if I go into our walking state, we switch to and play our walking animations. So we've now simplified our graph to use a single sequence player node. All right, everyone, that is going to be it for this video. In the next video, I'll show you how we can use animation layer interfaces to construct animation blueprints in a more modular way, which opens up a lot of possibilities. I'll see you there.